And here we are back at Advent of Code for day 7. 3, 2, 1. And we're in. No space left on device. That is not something I ever want to read. Okay, we can hear birds and raindrops and other stuff, which is kind of nice. The device the elves gave us has some problems. System update, please, pretty please with sugar on top. No space left on device. All right, time to do a Google search for the best way to find virtual elf files. You browse around the file system to assess the situation and save the resulting terminal output. Okay, so we've got terminal output here. This is starting to sound like we're gonna be building an enum. It's quite a bit of test input, actually. So one of you commented that we could triple click, and we can actually triple click to select just the input, which is wonderful. Thank you. Thank you, whoever said that. I appreciate that. Let me drop that quickly into our input. Make sure that this is something K at the end. Yep. Okay, so file system consists of a tree of files and directories, which can contain other directories or files. The outermost directory is called slash. What a surprise. If that is surprising to you, it's kind of, that's just the file system on a Linux or Mac OS or whatever. You can navigate around the file system, moving in and out of directories, listing the contents of the directory. Lines that begin with $sign are commands we executed. So we've got cd x moves in one level, cd ... moves out one level, cd / switches the current directory to the outermost directory, ls is list, and then we get all of the files and directories immediately contained by the current directory. Looks like they're on one line, so 123 abc means the current directory includes those two files, or includes a file named abc with size 123. dir xyz means that the current directory contains a directory named xyz. Given the commands and output in the example above, you can determine that the file system looks visually like this. Directory aei, fg, h.lst, b.text, c.dat, dj, dlog, d.ext, k. Here are the four directories, slash, a and d, and e. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Sounds like trees and recursion here. Directories themselves do not count as having any intrinsic size. Okay, E is 584 because it contains a single file. A has whatever that is because it's a couple of files added together. Okay, find all the directories with a total size of at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total sizes is whatever. Okay. Find all the directories with a total size of at most 100,000. What is the sum of the total sizes of those directories? So for our purposes, 95,437 is the answer here. And then part 2 needs to be ignored. This is our input, which we could potentially parse into something. So we've got some context, the folder we're in, and a list command executed inside of that folder. Presumably, we basically always start at the root. Let's check the actual puzzle input. The actual puzzle input makes us start at the root, so we don't have to assume that. So I kind of want to just build up a tree. I don't know. It looks like we don't have like a CD into multiple directories. So that's good for us because it means we can only go up one, down one. And I guess we'll just hope that is still the case. I think all of the CDs have a single identifier. There is no. So what I would be concerned about is doing like a ... or like a ... slash some directory ... some directory ... slash some directory. I bet you we could actually create a file tree for this, which would be funny. So let's get started with the parsing anyway. We can have a struct, or not a struct. Enum operation is either CD. We can make this a string slice. If we use references here, then we have to use named lifetimes, which is fine because input is going to live for the entire process that we use here. So this shouldn't cause us any issues, but it is easier to not use lifetimes and to use like a capital S string here. And then you don't even have to deal with the lifetimes at all. So keep that in mind. So we have CD and LS. We both have file and directory. So maybe we have file with a size that's a U size and a name that's a string slice, or a directory that only has a string slice, which is a name. I think that's all we need, right? We could do more for CD if we wanted to. CD could either be up or down like this. And if we do that, we have to pass the lifetime through. So this lifetime is propagating through all of these structs. I think we're going to try to do it with the lifetimes here just to show you how it's done. But I will again say that it is much easier if you use owned types. So use a capital S string if this is your first time using Rust. So I'm going to have a parser here that's command. This is going to use nom again. So it's going to be an I result with a string slice. And the response for command is going to be a command. Did I name this command? I already forgot. Operation is what I named it. We'll call that operation. I result needs to get pulled in because we haven't imported nom at all right now. So I'm going to do star there. Okay, so an command parser is going to return an operation. That operation will either have the cd command or it will have the ls. We're using nom, so commands always start with the question mark space. This is true for cd and it's true for ls. Of course, I do need to bring in tag and alt, which should work out for us. So any command line starts with a $sign and a space, then the name of the command, which is ls or cd. And we have two options here. Basically, we can either write like a parser that parses cd, and if it fails, we parse ls, or we can do it the way that I'm doing it right now, which is like match command. If it's ls, then we're done. Well, we're not done, but we do one thing. Let's write the full parser, actually. So this isn't going to be tags. It's going to be two other parsers. And then, of course, we don't need this here. We can put this in here. And this is basically going to be the same thing to start cd as well. So we'll bootstrap that. The red line over here, the squiggly line on both of these, is because we're not returning anything from these functions right now. So I could do to do return here, as well as to do return here. And what that'll do is if we run that piece of code, it'll panic. So if we ever hit line 19 or line 23, it'll panic. But in the meantime, we can actually set these functions up like we wrote them, like we actually implemented them. So we can do alt lscd, and that'll give us this or that, or this or that. And I think that's all we need to do. So maybe we do separated list 1, new line, alt. Is this going to work for us? I think it's going to work for us. So separated list takes a separator and the parser. So we're just going to alternate. It'll either be ls or it will be cd, or we'll be done. So I think cd is easier, so we'll start with that. It has to start with the $sign space. And actually we can just drop the cd in here with the space. And if that's true, then there will be something. So let input dir equals alt tag ... or alpha1 with the input. We haven't imported alpha1 yet, so we need to do that. So dir is either going to be ... or some letters. So we can match on dir. If it's ... then we get operation cd, and what, cd up or down. This is going to be up. Anything else is going to be an operation cd down, and that's going to be name, short for operation. And then we'll return OK, input op. And that should be okay for cd. For ls, it's going to be very similar. We're going to do $sign space ls space. No, we don't need space for ls. Then what we need to do is parse until we hit the $sign, basically. So I think we can do let input files equals separated list 1, separated by new lines, and then alt. And alt is either going to be a file or a directory, which I will spell as the full name because we used dir on line 30 and 31. We obviously haven't written the parsers for file and directory. I just want to give them names early. So file is going to be some usize and then a name, and then a directory is going to be dir and then a name. So we can do fn file input string slice, I result files. I think there's a separated pair, I think is what I want. Gets an object from the first parser, then matches an object from the sub parser and discards it, then gets an object from the second parser. That is what we want. So if we look at the stuff that we're parsing here, it's going to be that input and then a tuple for size and name. And that's going to be a separated pair with the input and the error handling. And the separated pair is going to be complete usize, which I'm assuming exists. but we might make this into a U32 or something. And then tag space specifically, because there's ever only going to be one space, and we know it's going to be a space. So we could put space here, but we don't need to match multiple spaces. And then we need something that is like alphanumeric with dots. So alphanumeric is 0 to 9, A to Z, and capital A to Z, but that's not really what we want. I think we're going to go with an any car terminated in a new line. We could also do one of and explicitly place in all of the alphanumeric characters that we need. So we could do something like many one of, and then I don't think this needs to be a string slice, does it? List T is generic. T needs to implement find token, I is input iter item. All of the examples are string slices. So I could be real cheap and run my hand across my keyboard from Q to P, A to L, and then Z to M, and then put dot here, which I think is just what I'm going to do. So many one needs an import, one of needs an import, separated pair needs an import, complete usize looks like it doesn't exist, so let's go check. U32 does exist, usize doesn't. We do have a toUsize function, which is on what? It's on the toUsize. So let's pull in a U32 here. That's got to be big enough. If it's any bigger than a U32, then I think we've got other problems. That is still giving us a problem, though. What did we do wrong? Complete U32. Let's just fully qualify this. Nom character complete U32. And then OK, input, files, file. And we get size and name. Name has an issue for some reason. Ah, right, because file size name, because this needs to be a files, not a vec of string slices. Name is a vec, which we really don't want. So many one returns a vec. If we look at multi, then we could use some of these other combinators for sure. I think we actually do get away easier using any car here, even though it's not exactly what we want. Actually, we don't, because any car is a single character. We want alpha 1. And that gives us a string slice here easily. We know that there's nothing that could possibly be here if we parse a number as the first line, because there is nothing else in this entire input that starts with a number. So that's fine for us for now, even though it's not exactly what we need. So that returns that. And if I copy and paste that and we get directory, we need a separated pair of tag dir. Well, actually, we don't need a separated pair, do we? We can just use alpha 1 there, and then we don't need a size because this is dir, and dir is just a tuple struct, which is a name. So if I've written that all correctly, then this gives us files for ls. So this is going to be, okay, input, operation, ls, files, and we need to get rid of this. This is going to be a command, right? Operation found struct vec. This is all of the commands. So let's do commands. And this is going to be a vec of operations. And then on input here, we do let cmds, short for commands, equal commands, input, unwrap. We debug commands, even though we haven't implemented it for any of these structs yet. So we are going to have to derive debug. Debug is a trait that lets us print out the debug form of all of these. So I'm just going to drop this on literally every enum and struct that we just wrote. And if we run cargo test, it should fail. And it looks like we are forgetting about one new line here. So specifically after command, maybe. So dir 14848 is this. So that is this new line right here. Oh, that's why. Because I forgot about slash for the root for CD. So CD isn't actually alpha 1. We actually have CD up, CD down, and CD... What just happened? I have no idea what key I just hit. What file are we in? We're in day 5? I think I just swapped workspaces or something. I'm going to close that out and open my project again. I'll have to look at the recording to see what I just hit. I have no idea what I just did. It was like Control R-ish or something like that. What was I doing? Root for CD, and then for CD, we're either doing ... alpha 1 or slash. And then slash here can be operation CD root, which is great for us. And that's how easy it is to add something in if you write it with nom and do it like this. So if I run cargo test now, we start off with CD root, and then we fail on new line. That is really interesting. Separated list 1, new line, Alt ls cd. So cd parses, and then we should hit new line. Unless I messed up the syntax for separated list 1. Separator is first, I believe. Yeah, separator's first. So we're good for our syntax anyway. CMDS is what we're logging out here. We either get an ls or a cd. We do parse a cd successfully, at which point we should bounce to new line, which it doesn't look like we did. I would say this was a good day to start talking about error handling, or rather error tracking, but I have a sense that this is going to be a longer video, so I'm going to leave that for another day. So lscd, lscd. Oh, is that because... Let's take a look at the alt documentation for a second. Takes a list of parsers one by one until one succeeds. Max of 21 parsers because of the size of a tuple. Alt, this, that. You'll notice this with a custom error type, it is possible to have alt return the error of the parser that went the furthest in the input data. That's what I was talking about with the error handling. It's interesting that it runs twice. So there's ls and there's cd. They both start with a $sign. Maybe I do input here too. I have a feeling that this isn't going to really tell us that much, but so we've got ls. ls should fail on $cd space. cd should succeed and gobble up $space cd space /, which it looks like it does. And then it tries to, so it gobbles the new line and then tries to grab an ls. So I must have messed up the ls parser. So that's because this has to start with a new line. So what's happening here is that $space ls new line, and then we have our separated list. So separated list won't start with a new line. I'm fairly confident that's the issue, so I'll remove the debugs. So we've got cd root, ls, and then a dir, a file. It says the name is b, but we need it to also include dot. So we've done something wrong there for the name of the file. So separated pair, it's not alpha1. Alpha1 is the wrong thing here, because we need to include dot. So the approach that I've chosen to take here, which you can see on the left is pretty successful, is to take the separated pair for the file name, where the left-hand side is the size, then we have a space, and then I ran my finger across the keyboard from Q to P, from A to L, and from Z to M, which is an American English keyboard layout, so it's just A to Z plus dot. And I believe that that gives us all of the input that we need. So we've got cd root, ls, dir a, file, b.text, c.dat, dir d, cda, dir e, f, g, h.lst. So this looks good to me. It's a lot of parsing. We should probably write tests for the parser. I chose not to. So I think that because we only ever do a single directory at a time, I could have another struct. So below all the parsers, we could have an enum that is like file system, where it's either a file or it's a directory, and the directory has a name, which is not the way that I do that. The directory has a name. The file has a size as a U32 and a name, again with the lifetimes, but remember, using a capital S string here is not cheating. You could totally do this and it would be fine. So one thing I'm really curious about that we don't know is if we get cd, we only get cd root once. So we never have to worry about cding to the root directly from any other place. So that's good. Context equals this dot to string or something. No, let's do vec of nothing, I guess, when this is really going to be a vec of strings that we create that is mutable. That is definitely a vec of strings and not a string. So cd gives us either one of three things. It'll either be a cd root, a cd up, or a cd down into some name. Cd root, we know only happens once. So we context dot push slash, and I think actually now that I think about it, this could be a string slice too. So let's do that for a moment. And then up is going to be context dot pop. So what we're doing here is we're building up this context, which is going to be the directory that we're in. So if we're at the root, if we cd into root, that only happens at the beginning of the input. So we pop that, push that into this vec. We're always going to be at root. If we go up, we're going to pop one off. So the context is going to change. If we are going down, we have to go down into a name. So we're going to context dot push name, and ls is a number of files and sizes or directories. So my question again is, do we cd into the same directory multiple times? I'm going to assume that we do. So we do have to keep track of all of the individual files. So if we do files, and let's do directories actually. Directories, because the directories are the only things we care about at the moment. Is going to be tree map, if I can spell, btree map new, which we have to import. Btree map is not, I didn't give it a type. So it's going to be a btree map from, I guess we'll just keep going with string slices, right? Is that what we have here? We have a name and a size. So we're going to have a string slice for the directory context, and then what I'm going to call a file, individual file, because we'll be able to tell which one is nested inside of which one from the name. So a file is going to have a size, that's a U32, and a name that's a string slice. And our test is failing, which is fine. ls is going to be a set of files, which is a vec of files. For each of these files, we push just the files in. So files.iter, for file in files.iter, or rather, we'll filter this out and do, so we can filter out here for file in files.iter.filter f if it's files file true, else false. Then we should only get files here, which I should be able to see. Yeah, only files here. And then for directories, dot push file, what is this? Size. So file.size and file.name would work. Actually, I'm not going to filter on this because we need to match anyway. So match file. We're going to copy and paste the code that we just had and drop it in here. And if it's a directory, we're just going to ignore it. So we're going to return unit there. And then directory is push. Why is push not available? Did I not make this mutable? Oh no, insert. Sorry. This is a btree map. So this needs to be insert, and these names need to be strings because these are going to be context.iter.collect into a string, which needs allocation, interspersed with slash. String can't be built from reference to string. Right. Intersperse is not on stable, but it is what I want to use because I want to put a slash in between all of these. So I'm going to go up to the top and drop this feature in. Instead of running on stable, we're going to do nightly. And then we're going to learn that file doesn't have the fields that I said it does, size and name, because those are already defined. So size and name. Intersperse, still not working for us. Did I not use the feature correctly? Add an exclamation point. There we go. We need an exclamation point for the language feature. Okay, so all of that to say that we have a set of directories. I didn't put derive debug on the file, did I? Boom, should debug out. So now what we have is slash for the root and then slash because, you know, that's what I did. We could replace that, but I don't particularly feel the need to, I guess. It does look a little weird though, doesn't it? So we could do this. We could push empty string and then everything comes out like this. It looks nicer, a little bit weirder to deal with. So we've got slash and then the name of the next directory and then slash and then the name of the next directory. This only gives us what? 1, 2, 3, 4 files though? Did we only have 4 files in the input? That doesn't sound right. C.dat. Where's B.text? Oh, because I made the value the wrong thing of the btree map. So btree map isn't file. Btree map is a vec of files, and they all have to go in. So this is, we could do this instead. We could do the directories insert empty vec, and then inside of this iterator, we do directories entry. I think insert is the wrong thing to do here. We'll do entry or insert vec. There we go. And then this will be entry end modify. We'll push this in there. That's why it wasn't formatting, because I had an extra file over there. So that all goes together, and then we look at the result again, and we get in the root we have b.text and c.dat, b.text and c.dat. We've got F, G, and H in the next one. F, G, and H. We've got I and AE. We've got J, D, D, K. So does that match what they told us existed for the files? Is the question. I is in AE. F, G, and H are in A. B.text and C.dat are in the root. And JDDK are in the /D directory. Okay, so now we have all of the paths for all of the directories. Okay, so what do we actually need to do? What is the sum of the total sizes of those directories? All the directories with a total size of at most 100,000. So we have this directories tree, basically, or this flattened directories tree that we have. And I think what we do is we accumulate this into another one. We're just going to be sizes, B tree map, string U32. I think it's going to be that equals B tree map new. This, of course, has to be mutable. We're going to take directories. We're going to iterate over it, which gives us the keys. So for path files in directories.iter, we're going to do path.iter, no, path.split /.iter. We don't need to iter because we already have it. I think that'll give us the root because the root / will give us the empty string. So our dirs are going to be this path.split, files.iter, .map, file, size. We don't care about the name. Size.sum, U32, size equals that iterator. For dir in dirs, directories dot entry, what is this called? Dir dot or insert size dot end. We'll do dot end. Actually, let's do or insert 0, and then we do end modify, because I think end modify runs. Let's go check actually. Btree map rust. See, modify an entry before an insert with in-place mutation. The entry API. Let's go check the entry API. Where is end modify? Provides in-place mutable access to an occupied entry before any potential inserts into the map. They use it before the or insert. So let's follow their lead. Instead of doing this, we'll do end modify some value v plus, I don't think we need to do the dereference. I think we already have it. V plus equals size or insert size. This dir is going to be a 2-string. This is going to be dereferenced, or it's not. What am I doing? Expected vec found U32. Why do we need a vec? Did I say it was a vec? This is sizes.entry. And then we get a U32 as the type there. So we dereference it, we do plus equals size, or we insert the size. And that will give us the sizes of every directory, I think. This is the most convoluted day we've done so far. Borrowed after moved. Perfect. Directories.iter. Is that here? Where did we move it? In the debug. So we can just get rid of the debug. Not an issue. So sizes are these. Those seem like big numbers. 94853, 94853, and 584. Okay, I'm going to go with, I think that these are right. 249-33642, 249-33642, 483-81165, 483-81165. So we're good. We have, this is everything we needed it to be. It was definitely convoluted. I did a lot today, probably more than I needed to. But this is what happens when you don't have a solution for the problem in your head when it starts. So I could go back and refactor this, potentially. I think the parsing was worthwhile. I think using a tree might help us a little bit, but not really. So what do we need here? We need sizes.iter.filter size less than 100, 000, right? That's what it is. And then we sum that, and then we 2-string it because I said that this return type was a string. 100, 000. Why expected string U32. So we're going to do, we don't care about the key. We only care about the size. And this is going to be a filter map because, actually, let's start off with a map instead because we don't care about anything else. So underscore size, we return size from the map. Yeah, size from the map. And then we can filter like this. We could do a filter map. I didn't want to. Expected enum option found bool. This no longer needs to be a filter map. It's just a filter. And then expected a reference to a U32. So let's do this. We'll destructure that. This needs to be some type, which is going to be a U32 for us. And our test is passing. So let's do cargo run bin part 1 with nightly, because we do need to do that with nightly. And apparently this is our answer. And if it's not our answer, then I will be sad. That's not the right answer. Darn. Answer is too low. So it's not the right answer. Your answer is too low. If you're stuck, make sure you're using the full input data. There's also some general tips on the about page, yada, yada. So 1,000 or 104,627.8. 1,046,278 is too low. So I'll screenshot that. And now we're in trouble because we don't have any other input to test, but our test passes. So cargo nightly test. Oh, this is not day 5. I should rename this. What is this, day 7? Let me save that. I should just call this day AOC in all of these. Okay, so our test part 1 is passing and we're getting the right output. Our running of the binary is not right. So there's something happening in our input that is not happening in our test input. And this is one of the really frustrating parts about Advent of Code. They send you through this whole thing that's just kind of like some hoops, and then the actual input does something else. So let's try to figure out what that can be. So what we need here is not DIRs. It's not a individual name for all of these, right? Because that's what I'm doing right now. Although of course I am splitting. So that's not what I need. What I need is every version of this, including the full version of it. So if we do underscore for dir in dirs.clone, well, let's do this instead. For underscore in dirs.clone. So dirs is going to be a vec of string slices. Then what we're going to do is for I in dirs, which is going to be now 0.dirs.length. Actually, I think this is going to be 1. No, it's going to be 0 because we're doing indexes. So for I in 0.dirs.length, dirs 0.i.iter collect into a string. And of course, this needs to be a slice. Value type string cannot be built from double reference to iters. That's fine. We can just make this cloned just for speed's sake. And now we have a very different answer. 421,522. And if that is our answer, then that was our issue. That's not the right answer. Too low. I should have known that. So now we're missing the JTW. So dirs.length. This is dot equals. Is that the right one? And now this is way bigger. 1, 2, 3, 4, 5, 6, 7. So 1644.75. That sounds like it's better. That sounds like it's higher at least. And that's the right answer. Okay. So it's been a long journey today. But the issue was that when I was iterating here, I was iterating and I was inserting just the name of the directory, not the path to the name of the directory. So if we had something like ABC, I was inserting the number into A, into B, and into C, instead of into A, into AB, and into ABC. So that's the issue. So if we do the cargo test, we probably see that now. So our test is still passing, but now instead of getting A and E, which is I think what we got earlier, I'll have to go back and check the video. We're getting A and AE. So that's the right, it was just this iteration right here. So I'm probably going to chop out all the debugging I just did because it's not super interesting to watch. But what it comes down to is that when we were iterating, the names we were using for the directories were A, E, and D, and not /A, /AE, and /D. Okay, part 2. Now you're ready to choose a directory to delete. Yay. The total disk space available to the file system is 7 million. I think that's 7 million. 1, 2, 3, 4, 5, 6, 7. 7D million. To run the update, you need unused space of at least 1, 2, 3, 4, 5, 6, 30 million? 3, 4, 5, 6. Okay. You need to find a directory you can delete that will free up enough space to run the update. So let's do this. Let's start with grabbing all of the logic that we put into part 1 and just running it all again in part 2. And the answer to part 2 is going to be increasing unused space by this much. So the number that so it's going to be the directory. Total disk space available to the system. So this is going to be the count of the size of each of the files. So this is going to be here. Let total size equals this number. So one thing we can do in Rust, which is really nice, is we can use underscores inside of our numbers. So if we want to do something like that inside of this 100,000 down here, we could do 100 underscore 1,000. And this just reads as a regular number. So it reads as 70 million and 30 million, but it's just nice for human readability. So we have the amount of used space for every directory in the file system already in our B-tree map. So all I need to do is get the root. The root for us is just an empty string. So if the file system size is this, and we need this, we can do this minus used equals how much free space we have. So total size of the disk minus the amount of space we've used. The current free space is this. The needed free space is this. Then we need to free at least the amount of space we need minus the current free space we have. So this number is the number that we have to be as close to but above as possible. So if we go for sizes, sizes will give us an iterator over everything. We iterate for size being greater than the needed, not the needed space, but the need to free at least. We don't want to sum that. We do want to collect it. So we collect that into a vec of U32s, and this is our valid dirs, and valid dirs dot sort. And a value of type vec U32 cannot be built from an iterator over elements of type reference to U32, which is totally true, but it doesn't matter to us, so we can just reference it. And now we need to enable our test. And I thought we needed this reverse here, but we do not need this reverse here. If we don't have it, then our tests pass. So if we run cargo nightly bin part 2, then we find out that that's not what we need to do, because we need to cargo nightly run bin part 2. And I want to debug out all of these values. So I'm going to do that just to just to sanity check, because we did spend a bunch of time debugging a pretty basic logic error for part 1. So used space is this 1, 2, 3, 4, 5, 6, 41 million. 1, 2, 3, 4, 5, 6. We've used 28, or we currently have 28 free. Was that 49, 69? Yeah, that looks like it matches up to 70. And then we need to free at least whatever this is, because we need to get to 30. That looks pretty reasonable. So since it looks reasonable, let's give it a whirl. And we got 1 gold star. All right. So I spent a bunch of time chasing. Well, let's look at the calendar, because looking at the calendar is the reward for getting our problem done. I spent a bunch of time chasing down a logic bug here. That was literally just I wasn't using the right names in my B-tree map. So let's recap what we've done here, because I wrote a bunch of code. I probably wrote more code than I needed to write. I'm fine with the parser. So for process part 1, we wrote this commands parser, and this commands parser gives us a list of commands. So we've got a couple of structs here. We've got an operation. So it's a list of operations that we're getting back from commands. If we look at the commands parser, we're getting back a vec of operations. We do this by doing a separated list of new lines for either ls or cd all the way down. ls is $space ls, followed by a new line, followed by some list of either files or directories. cd is the cd tag, followed by either ... / or a name of a directory that we're supposed to go into. We translate all of this into custom structs. So we've got operations, and we get a list of operations. These operations have tuple variants. So we either get a CD operation or an LS operation. The CD operation contains a CD that is either root up or down with a name, and LS just contains the vec of files that are in that current directory. We do everything with references here, and we really never ran into a problem. The reason we never run into a problem is because all of the references that we're using are references to this input string, and this input string comes from somewhere outside of the function, which means it will live until after the function. Specifically, if we look at the part 1 binary, we're reading in the string from a file. So this file is what needs to live. So we pass that in as a shared reference to process part 1, and this file owns that data, which means that after we use it here, after process part 1 handles it, then we can drop it. So that's why using references in all of these structs doesn't matter because the data that we're referencing is guaranteed to live until after the end of the function. So commands gives us that vec of operations. Then we set up a directory's B-tree map. A B-tree map is keyed by strings, and it's basically a vec of files for every directory that we have files for. Understanding this a little bit more, I think I can refactor this into a scan. So I might do that and then make another video about scan, because I think that would be a much cleaner way to handle this. But basically what we're doing here is we're matching on each of the commands in the vec in order. So it's either going to be cd root, in which case we call it empty string. Up and down are simply push and pop on this context variable. This context variable keeps all of the directory names that we have currently traversed into. So if we traversed into CDA, CDB, CDC, we would be in a vec ABC. When we ls, we kind of coalesce that variable into a string by merging it with slash. Intersperse on an iterator while it exists in the itertools crate on stable. In the standard library, it's a nightly feature. So that's why we're using cargo nightly. So we take that vec, we iterate over it, we clone it because we want to create a string at the end. We intersperse slash, and then we use the entry API to make sure that there is at least a vec there. It turns out that we only ls every directory exactly once, which I figured out while I was debugging earlier. For each file, we do the entry API again. We look for the same context variable again, and we modify it to push in that file. This gives us an actual representation of the entire set of directories as a flat B-tree map. So we've got a B-tree map with all of the full paths for each of the directories, and then all of the files in each of those directories. Then what we want to do is calculate the sizes. And I'm doing all of this kind of iteratively rather than collapsing it all into one little thing, because I feel like I'm never sure what Advent of Code is going to ask me to do next. So I tend to kind of just keep code around until I know what part 2 is. So we iterate over all the directories. We get the fully qualified path to a directory as well as the files that are in that directory. We split the path so that we get a vec of all of the names of all of the directories up to that point. So if we have a path of ABC or A/B/C, we will have a vec of empty string for root, then A, then B, then C. What we do then is we sum the sizes of the files in this directory using an iterator. This is a destructuring, so we just pull the field off for the map and we return it and then sum. And then for each item in the directory's vec, we look for an entry in this sizes B-tree map that is starting with the root, then the root plus A, then the root plus A plus B. And we do that by doing a slice into the dir's vec, which has all the names. We iterate over that, we clone it, we intersperse it with slash just for convenience, and then we collect that into a string to get the key name for the directory. So the fully qualified path for every directory from the one we're in all the way up to the root. If it exists, we modify it and we add the size. If it doesn't, then we insert the size. Of course, once we have all of the directories with all of their sizes, getting the ones that are either less than 100,000 or anything else is fairly easy. We filter out the ones we don't want. We map to make sure the size is the item type, and then we sum. And then we toString because that's how I have the function set up. And then part 2 is very similar. We do all of the same stuff until we get all of the sizes, and then we calculate the amount of size we need. We filter out anything that is less than the size we need to make up. We again map over it so that we just have the sizes, and we put those into a vec. Then I sort them so that the smallest value is at the front. I iterate over it, I grab the next one, we unwrap it because that next is an optional type, and that's the number that we need. So that's it. It was a bit of roundabout today. I think I'm going to refactor this because I kind of started off not sure of which path I wanted to take, and I think that really showed as I worked through the problem. I've written a lot of code here. I don't necessarily need to write all of this code. And now that I know exactly what I need to do, I could do something like go back and use scan or some other iterator and clean it up. So I hope you enjoyed that. And as always, if you have questions, leave them in the comments. Otherwise, have a great day.